Hello and welcome. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. This video, we're going to be focusing on how to do facial recognition for beginners. We're going to be using the face recognition package in Python, which is a very easy package to take in images, highlight where faces are, get the encodings of the faces, and then determine if an individual is in a photo or not. So without further ado, let's jump over to the Jupyter Notebook and we'll start coding. Okay, over in Jupyter, we have a blank notebook up, and we will start by downloading our very first package. So we are going to be using the face recognition package. If you're in Conda, you can do a Conda install C. It's going to be from Conda Forge, and it is called face underscore recognition. If you want to pip install it, you can also do pip install face recognition. I'm not going to run it because I already have it installed, but go ahead and get those. Other things we need PIL. So from PIL, we're going to be importing image. That's a capital I, make sure. And image draw. Also going to be importing NumPy as NP. And the last thing is we need to import that face recognition. Go ahead and run that and we will move on. Okay, so the first thing we're going to do is I have some images already downloaded. Go ahead and if you have an image that you want to use or go find one, I'm just grabbing an image of a group right now. But what we're going to do is we're going to say image is equal to, we're just going to have to open the image so that we can start processing it. So image.open. Mine's saved in a folder called inputs, and I labeled this first one as people.png. I'm also going to resize it because I know this one is fairly large. So resize, I'm going to go 1000 by 600. Now, if you open it using this method, you can do a display image, and it will show you what the image is. So this is what we're going to try to do. We are going to try to find these faces within the image, and then we're just going to, at first, detect where the faces are. So just literally put a box around the face, and hopefully it captures all 5 of these people in here. So what we'll do is, first thing, we need to convert that image into a NumPy array. So we'll say image array is going to be equal to np.array, and just pass it in that image. Now if I print image array, you can see it's just the pixel values of each of the pixels within this image. Okay. Now using face recognition, there is a module for doing this sort of face detection, and it's a very easy command. So I'm going to call it faces as the output, but faces is going to be equal to face recognition dot face locations, and all we have to do is pass it in that NumPy array of the image that we just created. This is going to return the location of every image, every face it detects within the image, and it's going to give us the top, the left, the right, and the bottom coordinates for that. So if I print faces just to see what it gives us, you can see I now have coordinates for each individual face in this photo, and it does look like I have 5 in here. What we'll do now is we'll actually just draw on this image to show where these coordinates actually correspond to. So to do that, we're going to use image draw, which is what we imported back up here. So we're going to say draw is equal to image, it's a capital I, image draw dot draw. This is how you initialize the image to get it ready to draw on top of it. And as you can see down here, it's a list of all these coordinates. So we're just going to go through one by one and draw a rectangle that's associated with that coordinate. So for face in faces, we're going to go one by one. Right now it is saved as top right bottom, and left. That's what each of those numbers are. And so we're just going to associate each one of those with that individual pixel value. Okay, to draw a rectangle, we can do draw dot rectangle. And now we need to pass it those same coordinates, but in a different format. So we need left, top, right, and bottom. That is why I saved it as a separate variable, because we just need to put it in a different form. Now, you could have just individually indexed the face variable and done the same thing, but this makes it a little more clear what we're doing. And I'm going to say the outline is going to be equal to, let's say, red. So this should put a red box around each of these individuals in the photo. And then to see what we did, we just do display. Now, when you do image draw, even though we created this new thing called draw, it's actually going to put all of this on top of the whatever you pass in here. So if we display image again, it's going to show the image, but with all of those drawings on it. Let me run that. Okay, and as you can see, it did capture each one of these faces, and now we do have a box around them. So that's the first step in the pipeline of face recognition, is just where are the faces within the image. Once we have the faces, then we can determine, okay, what are the features of the face? And then once we get the features of the face, we can encode it and figure out who that individual actually is. So I'm going to create another tab here, another cell. And now what we're going to do, instead of just finding where the face is, now I want to start highlighting some features. So where are the eyes? Where's the nose? Where's the mouth? Because that is what I'm going to use to try to figure out who this person is. So again, face recognition has this awesome set of tools, and it's super easy to get this sort of stuff. So I'm going to call this landmarks. And that's going to be equal to face recognition dot face underscore landmarks. And again, we need to pass it in that NumPy array of the image. Now what I'm doing here is I'm just going to add all of this on top of this image that we have here. You could re-import that image or change the name of this image up here in order to start clean, but it doesn't necessarily matter to me. Okay, so let me print landmarks. This may take a second because it's a fairly large list, but it went fairly quick. Okay, so as you can see, it's a list of a dictionary. So each item in here has the name of whatever it is. So here's the chin, so whatever feature it is. And then it has a whole bunch of points associated with where the chin is. And the next one, left eyebrow, same thing. So it's always name and then the point locations. So we're going to use that in order to actually draw that on the image. So like I did before, we're going to go one by one. So for landmark in landmarks, now I need to split this up. So I need to get the points in the name. So for name, points in landmark, and now this is a dictionary that's holding it. So what we're going to do is we're going to say dot items. So this is going to give me the name of the feature and then all of the points associated with it. And now we are going to draw a line on the image that connects all of those points. So draw dot line. We're going to pass in points, and we can come up with a fill color. So I'm going to say fill is equal to, let's do green this time. And I'm going to change the width to 2. You can mess around with different colors, different sizes, whatever you want to do. I'm just throwing something on the board right now. And again, last thing is to just display the image. Okay, now as you can see, those red boxes are still there from the previous step, but in addition to that, we also now have these lines that are highlighting where each individual feature are. So we have the some lines for the upper lip, lower lip, we have the nose ridge, bottom of the nose, eyes, eyebrows, and the chin. So this is the first step of identifying who this person is. But what we're really going to be looking to do in trying to identify who this person is how could we take these features and distinguish, let's say, this guy in the middle from this woman over here on the right? And what we're going to do is, first we need to, for instance, on this woman on the left, her head is tilted a little bit. So we need to square the face, and we can do that by just overlaying a typical template of a face, so where everything should be located. And that way we can distort her face a little bit to try to match that template, and so she's looking straight into the camera instead of a little crooked. So that's what we're going to do, but actually the face recognition, again, the package will take care of all of that for us. And once we have that, we are going to take encodings of each of these individual points, as you can see on the face right here. So instead of just taking the points, what we're going to do is we're going to maybe measure the distance between the eyes, or the distance from the bottom of the nose to the bottom of the chin, or whatever it may be. Actually, machine learning is going to take care of that for us. So it's going to figure out what is the optimal calculations that I need to make in order to come up with some list of numbers that can be associated with this guy, and it doesn't get mixed up with anybody else. So I can show you that in the next step. And to do that, I'm actually going to swap up the images quickly, because I need to have an image that I know one of the people inside of it. So I'm actually just going to take an image from Star Trek, just because it's easy and I can get a whole bunch of images of the characters. So I have this unknown image, we'll call it, and that has a whole bunch of people inside of it, and I need to know if the person that I do know is in the image or not. So unknown image is going to be equal to, now if you remember up top, I imported the image using PIL, and then I converted it to a NumPy array. Well, face recognition package has a built-in function to automatically do that for us. So face recognition dot load image file, and then go ahead and import whatever image that you want to use. I'm going to use the one I already have, which is called unknown.png. Now, the one thing that is different about this, doing it this way, is it's going to return this unknown image as a NumPy array already. So I can't go right ahead and display what the image looks like without converting it. So if you want to display the image first, maybe it makes sense to import it through PIL and not use this. If you want to just go ahead and send it right as a NumPy array, maybe use this one. But we can actually just say display image is going to be equal to image dot from array, and then just pass in that unknown image. It's going to take the array, convert it to an image. So now we can display the display image. Okay, as you can see, we have the crew of the Enterprise right here, and so we have a whole bunch of individual faces. And we could do basically what we did before, grab all of these different features and all of the steps that we did before. But right now, I'm more concerned with finding the faces, finding these features, and then coming up with an encoding to represent each one of these individuals that's different from each other, and that we can use to determine if a given individual is in the photo. Okay, so to do that, I do need a known image, because I want to figure out if my person is in the photo. So I'm going to take this unknown image, and I'm going to copy it and say the known image is going to be equal to, I saved this other one as known.png. Okay, I'm going to just quickly copy that to the bottom. And I'm going to change it. Instead of pasting the unknown image, I'm going to display the known image. So I am looking for Captain Picard. And so to do that, I need the encodings for his face specifically. Now, when you're grabbing an encoding for a face, you typically want to make sure they're pointing directly at the camera. His head is tilted a little bit here, but it should be fine. But you want a fairly good image just so you can get decent encodings for them. So let's go ahead and get those encodings. So we're going to say known encodings. That's going to be equal to face. Let me get my mouse out of the way. Recognition dot face encodings. We're going to pass in the known image that we just created. Now, the one thing I am going to do here, I know right now that there's only one face in this image. So this is going to pass me a list of all of the faces that it sees, but I'm actually just more concerned about the first one it sees, which is going to be the main image, the main face in the image. So if you have the group shot from before, you're going to have a list of all of these people. So you don't want to grab the first one. But just to show you, let me print the known encodings. And I'm actually going to drag that down below the image that I'm displaying. Okay, as you can see, we have the picture, but really what we're looking for is this encoding right here. So this picture has been distilled down, and this is now associated with his face. And it's just a list of all of these different floating points. But what we're going to do is, now we want to get the encodings for the group shot. And we want to compare each of those encodings to this individual encoding right here and see how far away they are. And if they're under a certain threshold, then we know that, well, we're highly certain that it's him in the image versus somebody else. So let's go ahead and do that. To do that, though, we need the unknown encodings. So I'm going to actually just copy this line for the encodings, paste it right under the unknown image, and just change everything to unknown. Now, like I said, this image is a group, so we don't want to get the first index. We want every single one of them. But now we have the known and the unknown encodings. Now we need to compare them. So to do that, again, another built-in function for face recognition. And we're going to call this just results for now. And that's going to be equal to face recognition dot face, compare faces. Now, compare faces is going to take known images, known encodings, and look in the unknown to see if it's there. So we're going to say known encodings, and then we're also going to say unknown encodings. So it's going to compare them, and the results are going to show whether or not that person is in there. So if I say print results, I'm going to go ahead and just get rid of all of this displaying the image and the encodings for now. But what it's going to do is it's going to look through the image and see if this known encoding is in the image with the unknown encodings, and it's going to pass back every single face that's in there, as you can see here. But it's going to say whether or not that person is our known encoding. So right here in the middle, this one is saying that one is Captain Picard in this case. But we want to actually see whether or not this was true or not. So let us take what we did in the very first step. So faces is going to be equal to face recognition dot face locations of the unknown image. So this is, again, if we scroll back up to the top right here, where we put these red boxes around each of the faces, we're just going to do that in this case. But I'm going to filter them down to be only where it thinks our known person is. So like we did before, we're going to do draw is equal to image draw dot draw, and then pass in our image. Right now, I got rid of it, so we don't have an unknown image right now. We have to go back up here under the unknown. We're going to say display image is equal to image dot from array of the unknown image. So again, converting the NumPy array that's spit out here back into an actual image. Now we can push that image into here. So we could say pass in display image. Okay, so now we're going to be drawing on that display image. Now for X in range. So I want the length of the faces. This is going to give me all the faces, and then I'm going to go face by face and say, is this the person that we care about? If it is, then we're going to print the box. If not, then we're just going to leave them blank. So if results at X. So if true is essentially what this is saying. Remember, it prints bools for false or true. So if it's true, then we're going to go ahead and make those boxes around his face. So remember, we have to convert the pixel values that are associated with it. So it's top, right, bottom, and left is equal to in this case, faces at X. And now we can do draw.rectangle, left, top, right, and bottom. And this time I'll keep it the same. So outline is going to be equal to red. Okay, so this is going to be a red box around him. And again, the last thing we need to do is display the display image. If I run that, okay. And now we have our image, and you can see his face is highlighted as the individual that we were looking for. If the person we were looking for is not in the image, there would not be any boxes here. If there are multiple pictures of that person within the image, there would be multiple boxes. So just a very quick way of showing you how you can do facial recognition within Python. I'm going to stop here, but there's plenty more that you can do with this. But the face recognition package really is super helpful and in doing this and doing it fairly fast and efficiently with very few lines of code. So I hope you guys got something from this. Stay tuned because I'm going to be doing more of these sort of face recognition tasks and different things that we can use face recognition and object detection for. So thanks for joining, and I'll see you in the next video.